inverse x whole square, then we need to find the nth derivative of y with respect to x at x equal to 0. So for that we are going to use the Leibnitz rule over here. So y is given to us, then finding the first derivative with respect to x, so we get 2 sine inverse x into the derivative of sine inverse x, that is 1 divided by square root of 1 minus x square. Very fine. Let's square both the sides and cross multiply. We get, this is 1 minus x square into y1 square equal to 4 times sine inverse x whole square. And now I can use this y equal to sine inverse x whole square over here. So this is equal to 4y, right? Taking this 4y to the other side, we get 1 minus x square into y1 square minus 4y. Please remember here y1 is your first derivative of y with respect to x. And now let's differentiate this with respect to x again. First function, the derivative of second, that is 2y1, and then y2, that is second derivative of y, plus second function, derivative of first, that is minus 2x minus 4y1 equal to 0. Dividing by 2y1 all over, we get 1 minus x square y2 minus x into y1 minus 2 equal to 0, right? And now we have to differentiate this n times by Leibniz rule. So let's apply this for the first term. So for this I'm writing nc0 and then the first vector 1 minus x square. Differentiating this n times, we get yn plus 2. Already it is second derivative, so if I differentiate n times, so it becomes yn plus 2. That means it is differentiated n plus 2th times, right? Plus nc1, and then differentiating this minus 2x, and then for this I write yn plus 1. Just one step back. If it is n plus 2, write n plus 1, one step back. If it is n plus 1, then we further write n. So plus nc2, and then now differentiating this, we get minus 2, and for this I write yn, right? Then applying this rule for the second term, taking this negative sign outside, so nc0, first factor, differentiating y1 n1 times, so I get yn plus 1, right? Plus nc1, differentiate this, we get 1, and then for this we write yn. Just one step back. We need to differentiate only till we get 1. So now I am having constant over here, so there is no need to write further step. Just stop over here only. And then minus, differentiating this term n times, we get 0. So this is equal to 1 minus x square. nc0 is 1. Then it is yn plus 2 plus nc1 is n. So minus 2x, I am writing here minus 2nx. Then yn plus 1 plus nc2, that is n into n minus 1 divided by 2 factorial. And I am having negative 2 over here, then yn. These two cancelled out, and managing this negative sign with this positive, we get negative sign. Minus nc0 again is 1. So this is x yn plus 1 minus nc1 is n into yn equals to 0. So this is equal to, okay, let's cancel few terms. So this is equal to 1 minus x square into yn plus 2. And then collecting these two terms together, we get minus 2n plus 1 into x yn plus 1, right? Then minus, okay, here I am having n square yn. So this is n square yn plus n into yn, that is cancelled out with this. Now because we need to find the nth derivative of y at x equal to 0, so let's mark this equation as 1, this equation as 2, the first derivative, and this equation as 3. From here I can get the second derivative, and for the further derivatives let's mark this as 4. So let's put x equal to 0 in equation 1. That is the given equation. So we get y0 equal to, putting x equal to 0 over here, we get sine inverse 0, that is 0. So this is 0. Now to put x equal to 0 in equation 2. From here, y10 equal to, okay, putting x equal to 0 over here, we get 0. Again, this term is 0. So y10 is also equal to 0. Similarly, we need to put x equal to 0 in equation 3. Sorry, this must be your third equation. Please mark this as your third equation. So from here we get x equal to 0, first term is y2 minus, second term becomes 0 and then minus 2, right? So this is y2 0 minus 2 equal to 0. That is y2 0 equal to 2. Very fine. Okay. Now let's put x equal to 0 in equation 4. We can get the sequence of derivatives at x equal to 0. So from here, if x equal to 0, we get yn plus 2 for the first term minus, second term vanishes, and then minus n square yn 0, right? Further, if I put n equal to 1 over here, I get y3 at x equal to 0 equal to y1, and y1 is 0. So this is 0. So y3 is 0. And then for n equal to 2, we get y4 at x equal to 0, we get 2 square y2. So this is equal to 2 square. What is y2? It is 2. Right? Please leave it as it is because we can get a sequence. For n equal to 3, we are getting y5 to be equal to 3 square y3 equals to, y3 is 0, so this is 0. For n equal to 4, we get y6 at x equal to 0, so this is 4 square into y4. What is y4? It is 2 square into 2. So this is 4 square into 2 square into 2. And so on. Right? So likewise, we can get y7 to be 0 and so on, right? So in general, we can get nth derivative at x equal to 0 to be, so we are getting 2 into 2 square into 4 square into, what number square we get? Let's check y8. By putting n equal to 6, we get here y80 equal to 6 square into y6. So we are getting y8 to be 6 square into y6. And what is y6? It is 2 into 2 square into 4 square. So next term is 6 square. And then so on. What will be the nth term? Can I write this as n minus 2 whole square? Yes. See, for n equal to 2, we are getting 2. For n equal to 4, we are getting this number. We are getting the terms when n is even. Otherwise, we are getting the result to be 0 when n is odd. Right? So this is the required nth derivative of y with respect to x at x equal to 0. Alright, thank you. Stay blessed.